Very good. Good morning, everybody, or good afternoon for some of you east of my position here. It's 1 minute past the hour. We'll get started today. My name is Joaquin Espinosa. I work for people with Down syndrome on a number of different capacities. Today, I'm wearing the hat of leader of the administrative and outreach core of the Include Data Coordinating Center. And today is our fall 2022 webinar, where we hope to keep advancing the mission of the Include Data Coordinating Center by demonstrating how to use the Include Data Hub. Now, before we go into the most important part of the day, which is the various demonstrations about how to use the Include Data Hub and do data analysis, I thought maybe we can warm up here by introducing ourselves in the chat. I see some familiar names, but also some new names, and I imagine the same is for you. So if you want to, just put your name, maybe your position or your interest in Down syndrome research or Down syndrome medical care. Very good. While you do that, while you all introduce yourselves in the chat, let me kick off today with a couple of slides here. Hopefully by now you're all very familiar with the Include Project. Best thing that ever happened to Down syndrome research field. This wonderful trans-NIH research initiative that has quadruple research funding for Down syndrome in the last 4 years. And this investment is allocated to three main areas of focus: high risk, high reward basic science, assembly of a large cohort study across the lifespan, and inclusion of individuals with Down syndrome in clinical trials. These are called components of the Include project. And component 2, this is relevant for today. Component 2 calls for assembly of a large cohort study of people with Down syndrome across the lifespan. And as part of component 2 activity, very early on in the Include program, NIH identified the need to create a data coordinating center to accelerate discovery of etiology and pathways underlying the co-occurring conditions of Down syndrome by facilitating access to and query of data from cohort studies of people with Down syndrome. And NIH already provided guidance about how the Data Coordinating Center should perform its activities, and the three cores, the administrative and outreach core providing management, outreach and education, and management core, data management core, providing data collection, processing, and harmonization, and a data portal core facilitating access to an analysis of data via an online web portal. So in 2020, we were very happy to be selected to run the Data Coordinating Center. It's a large grant with 7 different principal investigators listed here. Wonderful individuals, all of them bring complementary expertise to this very complex enterprise. I should point out this is a cooperative agreement with NIH, so everything that you will see today happening, NIH has been very involved. Our project scientist in the call today, Dr. Hui-Ching Lee from the National Heart, Lung, and Blood Institute, but also many other NIH officers helping us do this right. And why do you need so many professionals working in the Data Coordinating Center? Because it's a lot of work to make sure that the data being generated by the investigators funded by the Include project is identified, ingested, curated, integrated, harmonized, model properly. So then moving into the realm of the portal core, that data can be accessed, protected, shared, governed properly, also visualized and analyzed with the various online tools. So each of these individuals is an expert on each of these particular aspects of the life cycle of an Include data set. So we'll work together aligned to this mission, with this mission of accelerating discoveries that improve and enrich the lives of people with Down syndrome through accessible data resources that enable collaboration, connected communities, and the expansion of a global Down syndrome knowledge ecosystem. And how are we going to help people with Down syndrome? By decreasing the burden of what we call the co-occurring conditions of Down syndrome. Hopefully everybody in the call knows by now that for the first time in history, we have a sizable population of adults with Down syndrome that are included in society, receive proper medical care, but now we know that they are also highly predisposed to a number of co-occurring conditions such as Alzheimer's disease, autoimmune disorders, congenital heart disease, leukemia, COVID, autism, and so on. On the other hand, they're also protected from some medical conditions that affect the general population. Now, with that being said, it's also true that we can never generalize about people with Down syndrome. They are very unique. Each of them is dealing with the extra chromosome in their own personal way. And that diversity is what is going to enable us to make these discoveries. People with Down syndrome will teach us how to help them. Some of these individuals here may have multiple of these co-occurring conditions. Some may have none. Why is that? How come that there's so much what we call in science phenotypic variation? So there are many possibilities here. Maybe that their genetic makeup is slightly different, and that modulates the penetrance, the severity of the trisomy. It could be that during development, epigenetic mechanisms are modifying the impact of the trisomy. It could be that the transcription, the protein, metabolite, microbiome, immune profiles are different. And of course, there could be contributions of the environment, race, ethnicity, lifestyle, socioeconomic status, and cultural factors. Now, let me say this very clear. Not single study will be able to address all these questions. We're going to need to work together in an orchestrated collaborative effort to be able to test all these hypotheses quickly and effectively. And we will do so by being fair to people with Down syndrome. What do we mean by that? By making sure that all the data that is being generated in Include funded projects is findable, accessible, interoperable, and reusable. So in a way, you could think that NIH is tasking the data coordinating center with catalyzing a cultural change from data hardened to open science. The Include project is fairly new, 2018. From the get-go, NIH wants to see a data coordinating center that is going to help this revolution from publish or perish culture to open science framework. In a publish or perish culture, I was born and raised in it. I know it very well. Families with below one with Down syndrome made the contributions to the function of Congress. Then NIH receives a budget from Congress, and we, the researchers, want a fraction of those taxpayers' dollars to do research. We spend most of that money into generating data that more often than not ends in a black box, in my laptop, in a server at the university, who knows where. And then we slice that data to make a discovery, publish that in a high-impact journal with a very expensive subscription that is not fair to other researchers and other taxpayers. This culture has a number of issues, and among them led to a reproducibility crisis and a slow scientific progress. In an open science culture, the first part of the question is the same, but now we researchers are rewarded not only by publishing papers, but also making sure that all the data that we generated is not in a black box, it's somewhere where it can be findable, accessible, interoperable, and reusable. So in the open science framework, the data is open, any code or methodology is also open. The review process of our papers is also transparent. The journals are open access, even the educational resources generated by the scientific research are open. If we do this, we're going to help people with Down syndrome by creating a large cohort that is more than the sum of the parts with great sample sizes and statistical power, a more diverse integrated cohort that would enable the study of rare co-occurring conditions, also allow us to seamlessly navigate from children to adults, also assess reproducibility by setting up discovery versus validation cohorts. Through the portal, as you will see today, you will be able to explore data before embarking on expensive experimentations, also find biospecimens, and set up collaborations. So I'm very happy to say that earlier this year, many of you were there in March when we, on World Down Syndrome Day 2022, we launched V1 1.0 of the Include Data Hub. 5 studies participated in the initial launch, the Down Syndrome Registry DS Connect, the Serum Institute Human Trisomy Project, and these 3 studies doing genomics studies co-funded by the Kids First program and the Include Project. And later this year, we were able to add 2 additional studies, the Alzheimer's Biomarkers Consortium and a study from the Benaroya Research Institute. This is remarkable. Look at this. In March, all these studies released to the public 55 terabytes of unpublished data, 6,500 plus harmonized clinical profiles, more than 2,600 whole genome sequences, 400 plus transcriptomes, proteins, metabolomes, really leading the way when it comes to open science. I want to go out of my way here and really highlight the contributions from all these studies. The largest study in the hub right now is Down Syndrome Connect Registry. This is a participant family registry where the families provide answers to a number of questions about the health histories of people with Down syndrome. More than 3,000 participants have provided answers that are now visible through the data hub, although the DS Connect has more like 500 participants already. So this is participant survey data, and this teaches already the willingness of people with Down syndrome to do research. They are providing this data through DS Connect, and then we are presenting this data in a research-friendly format through the data hub. This is another large study that provides a lot of data out of the Synic Institute, the Human Trisom Project, data on 686 participants, very deep multidimensional data sets, genomes, transcriptome, protein, metabolomes, and we also made available our entire biobank, what we call the vitro biorepository, so that you can see all the samples here at the Synic Institute. Another study that I want to commend is this study led by Stephanie Sherman and Philip Lupo, also in partnership with the Pediatric Cardiac Genomics Consortium, PCGC, a large genomics study, almost 2,000 participants with some degree of clinical metadata. This clinical metadata will continue to increase as the years go by, but very importantly, whole genome sequences. How cool is that to have now more than 2,000 whole genome sequences available to the research community? Also want to commend the Alzheimer's Biomarker Consortium, ABCDS. These are the PIs they have provided already through the data hub, the clinical data for 400 plus participants. Now ABCDS, they have their own data sharing system. So soon we'll be providing an index of all the assays and all the files that ABCDS has generated that can be provided through this alternative data resource called LONI. And then last but not least, I also want to commend Dr. Buckner, Petridge, and Core for sharing this cohort at the Benaroya Institute, 167 participants, clinical data, and transcriptomes. So to wrap up here, I want to make sure that if you don't fully learn, if you don't become a super user of the data hub today, please don't be worried. We're going to have office hours every month. These are the next 2 office hours. In January, we're going to shift dates a little bit. Write this down, November 23rd, December 21st, office hours. You can come, bring all your questions, all your issues. I need your help also keeping our investigator registry updated and accurate. If you go to includedcc.org, our website, and go there to explore, you'll be able to find here all include funded principal investigators. I have pulled up here Philip's profile. Make sure that we are listing your grants and your publications accurately. If there are any mistakes, anything that you want to correct, please let us know. Send us an email to info@includedcc.org. And that ends up my warm-up. And I'm going to pass the virtual podium to my dear colleague, Adam Resnick, the leader of the Data Portal Core, who's going to introduce the work of the core before we go and start playing with the data hub itself. Adam, all yours.
Thanks so much, Joaquin, and it's a real treat to present. And what I'll do is just set up, a couple of the processes and workflows and overview of the way data comes into the data hub, in part because, as you'll see through the demo, that informs the way users can support their queries and use cases in the context of the data hub. I wanted to again, hone in on a couple of points Joaquin mentioned. The first is, our objective is really to accelerate the discovery process through a platform-based approach that leverages the cloud and other data-driven technologies across what is a very diverse user community. That's both a challenge and an opportunity. It's an area of innovation and an area we will want continued input from you as a user community to provide us guidance on how we can better serve you as researchers and stakeholders. A key opportunity and challenge related to that acceleration is this multiple types of data sources that we are provisioning for multiple diverse community stakeholders. And in order to succeed, we have to also engage this open science framework while still maintaining a framework of security and governance around these data resources. in ways that then drive a transparent and empowered framework for collaborative discovery. As Joaquin mentioned, no single study or single institution will be able to accomplish the mission of INCLUDE, and in order to support that collaborative framework, we are implementing and deploying tools and resources for that as part of the data hub that you'll see. The methodology we employ is really this framework, recognizing that cohorts begin with either data, annotated samples, and that our job on the INCLUDE Data Hub is to transform that data and sample information in the context of, let's say, clinical data into harmonized data that is true information that is queryable and usable by the community in a unified framework that brings cohorts together. And you'll see that as part of the demo. And then ultimately support that accelerated use of those resources for analysis and development of new knowledge and translation into impact. And we have to do this across very diverse clinical, phenotypic, self-reported data, as Joaquin mentioned, as well as through genomic data. You'll see in the portal the implementation of ontologies, and ontologies are the key layer that really empower that data to information framework for clinical, phenotypic, survey, and participant-reported data. It encodes the information and as a set of concept that then can be computed against and queried across cohorts in a uniform framework. And you'll see that implemented, and we are employing several ontologies that will cover the scope of the data sources. Genomic information is also harmonized, and it's harmonized through tools and resources in Cavatica, a cloud-based environment that you'll see in operation. But importantly, the Cavatica environment is both a tool and resources we, as a data hub team, utilize on behalf of harmonization and use of the data, as well as you, as the community, will utilize for large-scale genomic analysis. And what that means is that all the tools, pipelines, and workflows that we use as a data hub coordinating center are also available for you to apply on your own data in the context of the cloud, as empowered by newly available cloud-based credits and resources. And that data then, a portion of it becomes searchable and queryable in the context of, for example, variants, which will be upcoming and that JP from our team will highlight towards the end of his talk. But essentially, a data set has to go through a large number of permutations and preparatory steps. And this is not a process we do independently of the data generators themselves. And it's not a process that is stagnant, meaning it's a continual process of curation, harmonization, and integration of data, beginning with engagement of the scientists and investigators themselves, processes of cleaning, uploading, and annotating this data in ways that makes them empowered for the portal and other resources to utilize that data. The data is provisioned as exchangeable data with both the portal and other endpoints, and then is cloud empowered for users in the context of Cavatica or other sources. One question we often get when we start talking about access to data is, what can I access and how can I access data? And that's because the cloud empowers new ways of using data for the community. A traditional model is one of coming to a resource and downloading the data. Our data really falls into a number of different categories. We think of data as open tier access, meaning that anybody can essentially access the data without any logons or exchange of information. And by and large, all of our open tier data is within the INCLUDE Data Hub website. And we will continue to inform additional materials into the website, like aggregate cohort information. Within the Data Hub itself, once a user logs on, and you'll see a demo for that, you enter what's called a registered tier framework, where users essentially have had to register as users of the portal. And that does two things. One, it fulfills requirements by NIH and data stewards themselves, as well as provide you a way to have a saved state, meaning, and you'll see that in the portal, your own personalized environment with the information about the queries and workflows and your engagement of the Data Hub as a safe state for you as a user. In that safe state registered tier framework, you'll be able to access a number of clinical and phenotypic variables that will allow you to create cohorts across biospecimens, participants, and data object or files. Some of the data objects or files themselves fall into what the NIH deems as controlled access. And all that really means is that you have to apply through a standard dbGaP access workflows for the use of controlled access data. And this is really a layer of protection defined by the NIH for the use of genomic data. Even though data are de-identified, genomic or comprehensive genomic data can still be more sensitive than other data variables. And as such, you have to apply for each of the studies through dbGaP. Now that process really only assesses, one, your commitment not to identify, by and large, not to identify participants, to adhere to the constraints of, if there are any, for the user consent, and to appropriately manage and store data. So the burden of access for dbGaP is really a submission to the NIH dbGaP process. And once you have permissions, the systems that are being deployed, and you'll see that at play, understand and know who you are and what access to what controlled access data you might need to utilize, but the system should make that very easy and seamless for users to intersect between registered and controlled access data. And as Joaquin mentioned, we're also really excited to experiment with the idea of connecting across a federated framework of data, recognizing that not all Down syndrome related data sets will always be hosted and managed by the data hub, and that there may be other data storage environments that a user might have to interface with. And again, we'll be piloting and advancing this capacity of users to engage and interface with other sources like ABCDS. So with that, as a framework, I'll turn it over to JP and Vincent from the portal team, who will go more deeply into the portal itself and present about its features. But please, a key message for us on any of these webinars is the recognition that this is going to be an ongoing development process, one of engagement and input, and that we highly encourage and wish to get input from users, the users community, about their met or unmet needs and or processes of improvement as we continue to develop the resources. All yours, JP.
Thank you, Adam. And before JP gets us going to the juicy part here, I want to make sure that what you just said about receiving candid feedback can happen right now. So I'll be monitoring the chat here for any questions that you may have. Let's make this an interactive webinar. If you joined the call late, we have asked all the participants to identify themselves, maybe a description of the position or relationship to Down syndrome research. And yeah, I'll be monitoring the chat so that we can address any questions you may have in real time. All yours, JP.
Thanks, Joaquin. Thanks, Adam. So my name is Jean-Philippe Sibert. I'm the product owner for the Include Data Hub portal development team. I'm at the St. Justine Research Hospital. And so today, as Adam and Joaquin mentioned, we're going to be doing an overview of the Data Hub itself and how it can really drive discovery across how it can really drive discovery for trisomy 21 and its co-occurring conditions. And so since the March launch, we've added a few features, but more importantly, we really added 2 data sets. So we'll be showcasing all of those new hot features in this demo. So I'll just click here. So the portal development is really following a phased approach. So the phase 1 main objective is really to to support data exploration and cohort building. And the reason we want to do that is by doing cohort building activities, you could identify a certain research question or a hypothesis based on a phenotype, let's say you're interested in. And from that, you could also identify biospecimens that are associated to participants and data files. So this is where we really created the virtual biorepository. And the idea of all of that is that we're leveraging these cohort building activities to support cloud-based computational framework for analysis through the Cavatica platform. Now, we've completed the phase 1, and so we're going to be discussing a little bit later on in this presentation about the phase 2 main objectives. But as next steps, we wanted to enhance the data exploration tool, so the phase 1 product. And a more exciting feature here will be for phase 2, will be the integration of the germline variant database. So you're going to be able to explore the rich genomic data sets that we have for the variants of the Include Data Hub participants. And finally, we're looking into implementing the first online data analytics and visualization tools for really more so of a web-based online tool to facilitate and make it a little bit ease of use for non-bioinformaticians. So, oops, there you go. In terms of the, I think I skipped that, yeah. In terms of the portal demo, I'll be going over the registration process, the authentication, through Google and Orchid. I'll also be discussing the dashboard, so that's your customizable space where you're going to be able to connect to platforms for data access, and you'll also be able to manage data from there. And finally, the biggest piece of the presentation will be on the data exploration, where you're going to be doing browsing the data, you're going to be building virtual cohorts, visualizing it, accessing it, and analyzing it. And finally, in terms of interoperability with the Kavatica cloud-based environment, we're going to be copying data files from the Include Data Hub into the Kavatica platform just to show that interoperability. So in terms of the URLs that we have here for the Include website, we have includedcc.org. So the website really covers all sorts of information on the Include program, whether that be the studies, the researchers, guides, and whatnot. For the portal itself, we have portal.includedcc.org. So I encourage everyone to follow along as we do this demonstration, and maybe it'll trigger some questions. In terms of feedback and guidelines, as Adam mentioned, we do have here a user snap framework where you could essentially take a screenshot of a problem or a question or a recommendation that you have using the portal. And so you could submit that feedback here, and you could submit that, and we'll receive that on the within our internal team. Secondly, as a reminder, we do have the Help Center. So that's help.includedcc.org, where there is a lot of onboarding, step-by-step instructions, information about data access, what you could do in the portal. So the website team did a very good job in providing more insight and clear instructions for the portal itself in case you miss anything on one of these. But again, we do have office hours and whatnot. So feel free to post any questions there in the forum. And finally, we also have the email, so the support@includedcc.org. So I'll jump in right into the portal here. So as we jump here to the portal, we have here the available data statistics for the studies, the participants, the biospecimens, and the data files, and a short description of the mission that we have here in terms of supporting trisomy 21 and co-occurring condition discoveries. So I'll first start by doing the sign-up process. Oh, sorry about that. It seems I was already logged in. So if I just take here the ORCID login. So once you do submit here, go through the authentication process of our Keycloak, whether it be via Google or ORCID, you'll be redirected here to the portal registration process, where essentially you have the terms and conditions and the portal disclaimers. And then if you do submit and adhere to the conditions and you click next, you'll be prompted to the user intake form. So this is just information that we collect here. So I could fill that out very quickly. So this is just your name, your affiliation, what you're doing with the portal, and the data itself. And so we'll just fill that out really quickly. We could write aging biomarkers. I do encourage everyone to provide a little bit more information, as much information as possible when filling out for the research area of interest, because this information will be shown in the community page. And so we want to have some rich interest here and build a network of users. So the more information we have, the better. And so you just have to select here and you click submit. I already have an account, so I'll maybe skip this step of creating another account. And I'll just go up here And so if you do have a successful registration process, what you'll land on is the dashboard here. So the dashboard is your customizable, personalizable space where you could access, manage data, and you could connect to external and internal platforms. And so in the future, we're going to be interested in having the analytical portion of we're going to be including analytical tools. And so you're going to see more widgets here to do that as part of phase 2. So giving a quick overview here, we have the authorized studies, which is what Adam mentioned earlier on in terms of data access. So we have 2 types of data access. We have registered tier, and so that anyone that logs into the portal is now has access to registered tier data. However, we do also have control data, which is a little bit more the genomic sensitive data. And so as Adam mentioned, you do have to go through a dbGaP approval process, which is linked to your Era Commons account. And so you could connect here. I'm already connected because it remembered within my account. And so you simply have to connect there, and it'll, once your Era Commons login is successful, then you'll see these similar information here if you do have access to that. And so you could click on the specific files and whatnot, and it'll redirect you to the data exploration page. Next, we have here the Kvatica projects. And so what Kvatica is a cloud-based environment where you could share data, not only from the Include Data Hub, but incorporating other genomic platforms working with the NIH. So it's really an interoperable platform where you could do data analysis, downstream data analysis. So you'll have here your different projects, and this is really connected live with the Kvatica platform, and I'll show you a little bit more on that, and Matt will also following my presentation. We also have here save filters, which is essentially while you're in the data exploration tool, I'll show a little bit more on that later. You could save essentially facets, your search criteria, and then instead of going through the same process a second time and selecting all your search criteria, then you could save that for a subsequent interaction with the portal afterwards. And so this is going to be saved for your profile. And similarly, we have save sets, which is an unordered list of entity IDs. So this covering the participants, the biospecimens, and the files. And so this list will be static. So if there is an update in terms of the data release, this list will not change. And so you could reuse these specific participants or biospecimens for later use as well. In the future, again, as I was mentioning, within the analytical tools, we'll be utilizing these save set widgets and these save set lists, to function with the analytical tools. The we have a few redirects here. Again, as I was mentioning, the Help Center, which provides, again, some step-by-step instructions to help facilitate users to navigate the portal. We also have the website here. And we have the community page. So the community page is one that we definitely improved on since our last launch. We have a much more friendly user interface and in a much better search functionality. So you could search by name, by affiliation, and you'll have here cards demonstrating your profile. So here, if I were to write SAGE, which is our counterparts at the DMC, the Data Management Core that work on the data management, you'll see that we could search by affiliation. You could filter by different roles. So this is essentially the list that you saw in the click-through agreement when you're registering. You could also search by data use. You could clear your filters, and you could sort here by newest, oldest, first. And so if you do have, so this is my profile that I used here. And so you'll see, again, this is what I was mentioning. The more information you put, the best, because we're trying to build a network across all the users, the researchers, the community members, and clinicians and whatnot. So the more information you put, the best, the better it is.
And
so
JP,
yes.
Am I the only one who volunteered a headshot for this? That can't be right. Here's my call to action. Don't leave me alone in putting a picture from 20 years ago here in my profile. So many wonderful researchers being part of this community. Don't be shy. Thank you.
That's a good point, Joaquin. And so you could edit your profile in case that you do your research interest change, your data use changes. So if you click here, then we now have a profile settings page where you could essentially put your first name, your last name, a public email, a LinkedIn address here. And we're looking in the future to add a few more addresses like your ORIC ID or Google Scholar, for example. And so you could adjust all that information here. You could also delete your account if we provide that option as well. And so you could also get to this page by clicking on the profile settings here if you desire. So now getting to the studies page, again, here we have a list of all the studies and data sets that we have within the portal. As Joaquin and Adam mentioned, we did recently just add the core data set, Benaroya Research Institute Down Syndrome Registry, and the ABCDS, so the Alzheimer's Biomarker Consortium Down Syndrome. And so what this page gives is just a general overview about the name, the program that's listed for the study, the DB gap, accession number, and various metrics in terms of the data that's available. And so you really see the different types of contributions. As Adam mentioned, we have here some participant-reported programs, which is DS Connect here. We have the institutional programs doing research on Down syndrome, so the HTTP study. We have cohort include cohort studies, and we also have the consortia-based studies, which is the ABCDS. And so you'll notice here that, for example, ABCDS doesn't have other metrics for data, and that's because they have their own data coordinating center resources. And so we have here the clinical participant data, which you could develop, you could create a clinical data manifest. And so if you are interested in the associated data files, then you could go through their data request form process here simply by clicking here, and you could go through that process to gain access.
JP, I would like to use the opportunity here to elaborate a little more on the ABCDS. So the Alzheimer's Biomarkers Consortium Down Syndrome, this is the largest study of adults with Down syndrome with a focus on biomarkers of Alzheimer's disease. Very rich, very deep multidimensional data. And they precede the Include Data and the Include Data Coordinating Center. So they were already set up with a different data access and data sharing platform. What we would be doing here in the next few months, we'll be able to give access to the Include Data Hub users to an index of all the data types and data files that ABCDS has produced, even if we don't give access through the Include Data Hub. So you would be able to see that ABCDS does have genomics, transcriptomics, proteomics, metabolomics, brain imaging, other things. It's just, and you will be able to create a cohort that includes ABCDS files. It's just that those files won't be directly accessible through the Include Data Hub. So I want to clarify that, because those who are familiar with the ABCDS study here in the call may recognize that they do have that data, and that is correct. It's just that we're not presenting it right here, right now. And there's a question here in the chat. Okay, I see that it was only to me. If the participant tab means participants, and that correct, that's exactly what it means. The participant tab is the participant level information, of course, de-identify information. Thank you, JP, for allowing me to comment on that. Back to you.
And so that covers most of the information I want to discuss in terms of the studies. If you do want more detailed information in regards to the studies, you could also click here on the code itself, and it'll give a little bit more information on the study. And maybe at times you'll have a redirect for the specific website. So now going to the data exploration, so the more interesting piece of this demo. So you'll notice here on the left-hand side that we have 3 different entities. We have the participant, the biospecimen, and data files. And so the goal really of this data exploration tool is to build virtual cohorts based on a specific research question, general curiosity, or if you have a hypothesis. And usually how people go about it is that they go through they have a specific phenotype or a diagnosis of interest, and they filter out and build a virtual cohort from there. And so one important feature here, so every specific entity has specific search criteria. So the participant's a little bit more clinical, demographics, whereas the biospecimen, you could have a little bit more information in terms of what sample you're looking for. If you're looking for plasma, DNA, RNA, etc., whole blood cells and whatnot. And so for the data files, you'll also have the access here. You'll have the types of different types of omics that we have, genomic, transcriptomics, etc., and the data types and whatnot. And an interesting feature and a really cool one is that these three entities are intersecting across one another. So what I mean by that is if you do add a specific search criteria, so let's say here we add the filter for sex male, and we add, let's say here, celiac disease. You'll notice that the table updated across the three different tabs. And so what this really means here, we have the participants that have 146 participants, and we have the corresponding biospecimens to these participants and the data files. And so what you'll see is that we have various different studies, of course. And so if you filter by certain studies, let's say we filter by HTP, for example, we'll see the corresponding row level participant data and their corresponding biospecimens. So this is 119 biospecimens corresponding to the participant 0070. And so if you—
JP, I just got a question that I think this may be the right time to answer, which is in the participant tab, what do we mean by family, right? Because, you know, DS Connect has 3,000 plus participants. How come there's only 20 or so families? And here we are referring, of course, a participant has a family, right? It goes without saying, but then we may not have data through DS Connect on, say, the mom, because the questionnaire in DS Connect is about the self-advocate with trisomy 21. Whereas in other studies, because of the design of the study, there is data on the sibling, or there is data on one of the parents, or more than one of the parents, in which case, if the information is provided to us by the studies, we can link and say, hey, this is the proband, the participant with trisomy 21, and there is, you know, a sibling and a parent. That will be a trio, or there may be a quartet, so on and so forth. And for some types of studies, this information is very important, because for some type of studies, you know, having the sibling or the parent is important for how you analyze the data. For the studies having an unrelated control, it's more important. So I wanted to tackle that when you see that disparity between number of participants and number of families, most likely is because the study was not set up to collect information on other members of the family. Thank you, JP.
Thanks for that, Joaquin. So going back here, in terms of the participant tab, this is a general information that you'll have. You'll also be able to save a participant set. So as I was mentioning earlier, if you're interested in this specific query, so you could select all the participants, and you could save this query into, you'll see that it auto-populates based on the filter criteria, and you could save that for later use. And so if I go back to the save sets, you'll see that this was updated automatically. And so if I click that, it'll bring me back to the specific set. So I'll just close this. You could also download specific clinical data. So this will provide the information that you see here on the table, but we also have a few more fields within that clinical manifest if you do a download. I also wanted to just showcase the summary view here, which is essentially a visualization of the different data aggregates. So currently we have a few charts where you could, these are movable, similar to the dashboard. They're clickable, so it's all interactive. And so you could click here and I'll add here the sex male, let's say. You could do that across all the different charts here. So it could be proteomics, for example, and you'll see that it was added here. you could also have here we also have the sunburst, which is an interesting feature, and I'll discuss this a little bit more with the ontology browser here as I go into it. But essentially, you could drill down a specific, you have a certain phenotype, a hierarchical view of phenotypes. And so one thing you could appreciate from, since we're handling multiple different studies, some studies may label a specific phenotype differently from another study. And so this was a part of the DMC's work of harmonizing and aligning all these annotations so that using our HPO and Mondo ontologies so that we're all aligned. And so I'll showcase this a little bit more in the browser, the ontology browser in the facet here, but you could, within the sunburst, you'll see that you're drilling down, you have the highest node of a phenotype. And as you drill down and get more precise, then you could select that and you could add that to the query. And so this is a specific abnormal heart morphology here. And you could also click here to add other phenotypes, let's say. Another way to add a phenotype is here. So I'll just click here again. So here, this is what I was just mentioning here in terms of the ontology browser. So again, we have the highest nodes, and so we could drill down to a specific phenotype of interest. So let's select here abnormality of cardiovascular system. What you'll see here on this column is that 78 participants in the Include Data Hub has the exact HPO term for abnormality of cardiovascular system. However, we do have 3,308 participants that were annotated based on phenotypes falling under the umbrella of the abnormality of cardiovascular system. So as we drill down, you'll see that we have abnormal heart morphology, and we have 391 with this specific term. So we could select this. And you'll notice here that we also have the 3 dots showing for the different operators. So any of essentially is an or statement, all of is an and statement, and none of is, well, simply excluding the specific phenotype. So we could add that. Oh, wow, sorry, I didn't realize that was the same phenotype. And so as you...
So can I pause there? Because what you did is likely to be, what you just did when you said none of, is to be one of our most common use cases. You know, we're going to have many of the wonderful researchers on the call trying to set up comparison groups, you know, of persons with Down syndrome with versus without X, Y, and Z, right? So, for example, your first filter here, Q1, you know, the researcher is interested in males with celiac disease in the HTTP. Now, would you demonstrate how you would set up the right comparison group? And that would be male without celiac disease in the HTTP, which you mentioned that briefly, but maybe we want to pause it and demonstrate how you would set up the comparison group.
Sure. So that's actually perfect because you showcase the fact that you could duplicate this and it'll save a little bit of time. So let me, there's a few ways that you could do this. So either you select directly the facet, the pill, sorry, for the celiac disease, and you could simply click on none of, and that's going to be the comparison group. So you could do it directly from here. So that's a little bit more accessible than going through the HPO browser again. But again, as I mentioned earlier, you could click here, none of, and then you'll have that comparison between both this query and this query where you're going to have none participants that don't have or weren't annotated with celiac disease. And so what you could do at the end of this is that you could filter out all the data files. Let's say that's the end goal, is that you could compare the data files, or let's say the whole genome sequencing or aligned reads of this specific query cohort, virtual cohort, and you can compare it to this virtual cohort as well, which has different data files as well.
Beautiful. So it seems to me like the fastest way of doing it would be you create a filter for the with, then you duplicate that and change it to without, right? And that gives you the 2 comparison groups. And how reassuring it is to look at those numbers. We know that celiac disease is more common in Down syndrome than in the general population, between 5 and 10%. So there we can see that in the HTTP study, out of 300 and 25 males, 2022 have celiac disease, which is about the number that you would expect. Thank you, JP.
Perfect. Thank you, Joaquin. And this is actually a great segue because I hadn't touched on the query management portion yet. But you'll see here that we have different options and buttons on the top, and this is what we call the query management bar. And so if you're interested in having, again, this save filter for a following session, then you could have here, I'll just write celiac disease, male, and HTP. And that will be saved for later use. And so you could, again, you could save it, you could create a new filter, you could duplicate this whole filter, you could delete it, and you could share it with different users. So this is also a very useful tool. We also have the My Filters dropdown. So this is, again, just a quick access. Instead of going to the dashboard to select one filter to the other, then you'll see it'll bring me back to the filters that I had selected. We also have here the manage filter, which is, again, is just an ease of access where you can rename, delete, more of a global view instead of clicking one by one. And so this brings me back to the biospecimen tab. And so the biospecimens is what we call the virtual biorepository. And the goal here was to drive discovery of biospecimens based on participants that are and data files that are associated to specific biospecimens. So as I mentioned, we have a myriad of different types of sample types. So plasma, blood, and whatnot, DNA, RNA. And another cool thing about this is that we're trying to get a connection with biobanks, and that's one of the end goals in the upcoming years is to have a live update of this type of virtual biorepository where you're going to have different samples that are available and whatnot. So you can see here that there are various samples that are available. If I scroll down, I could also select, you could see specifically there's a filter for available biospecimens. So if I select that you're only going to have samples that are available. So what we see here is that we see the aliquot sample level, we have their parent sample level, and we have the collection ID. So we have the lineage of the processing, pooling, and aliquoting event that happened across the sample's lifetime. And so if I select here a collection ID, so this is the highest level of the lineage, we should see all the different types of samples that came from this specific whole blood sample. And so you'll see blood, plasma, different bloods, and I'm sure here on the left-hand side, yeah, okay, so that covers all of them essentially. And similar to the participant tab, you could select different samples of interest, and you could save that here as a set again. And you could also download sample data so that you have a manifest of some sort. And in the future, we're going to be working on a biospecimen request form. So currently, if you see that a sample is available, you'll need to contact the HTP team directly. And you could do that by visiting their website on the includedcc.org website. They'll have their external website there. And so
thank you, JP. And I would like to comment on that a little bit as the principal investigator of the HTP Biobank. We are working hard to achieve two things that JP just said. One is to have real-time updates of this. This is the virtual biorepository as of launch, as of March. And we are working with the DCC to be able that every week or every month you can have a refresh of this. But some of you have already contacted us after seeing that we have this type of samples. We are also working towards have a more automated way of turning in this request. We're not set up that way yet, and there are some IRB considerations to take into place, and requests need to be evaluated by a steering committee at the Human Triton Project Biobank. But we wanted to, build something that is of some use, even if it is not the full picture yet. If you see biospecimens here that you care about, do go to the HTTP website. You have an email address there where you can send us a note. We check that email address, so you can write to me directly, and then we'll put you in contact with the proper sample request procedure. But we are mindful, that at this point you cannot request samples directly from the data hub, but that's something that hopefully we'll be able to do in the future.
Yeah, and I just wanted to comment on that, again, just to reiterate, that to our knowledge, there are very few portals or resources that present this kind of combination of biospecimens and data files and participant information in a combinatorial fashion. And so for us, as I mentioned at the very beginning, it's an ongoing process of development. So, Joaquin's point around the biorepository are, very salient because, this is a new model of really having transparent resources and leveraging centralized portal experiences that engage and connect to the stewards of those resources. So again, as Joaquin mentioned, this is something that we'll develop on, iterate on, and it'll likely be the case that for across repositories, we'll have to implement multiple different solutions. And our hope is for the INCLUDE program to really be a hub of innovation around how to accomplish this. And so again, it's an opportunity for your feedback and input as we move forward in this setting.
And Adam, this is a great way for INCLUDE researchers to find collaborators, by letting people know the biospecimens that you have, people may have great ideas about what to do with those biospecimens, but if you don't have a website advertising, your biobank, if you don't have the equivalent of the Trisom Explorer for the Human Trisom Project or what have you, you don't need to build one. Come to INCLUDE, Data Coordinating Center will build your vitro biorepository here, and furthermore, it will be harmonized with other vitro biorepositories so that collaborators can assemble synthetic batch sample batches across multiple biobanks.
And one thing that I forgot to highlight, and just to reiterate the fact that since we have multiple studies here, they were annotated based on phenotypes and diagnoses. Most if not all, if I'm not mistaken, you'll notice here that we have 3 studies that have phenotypes, for example, and we could also have let's say here we have 5 of them here. One cool feature is that you could combine queries. So essentially what this means is that we have here the phenotype for abnormal heart morphology and also the sleep apnea, and you can change the operator here and an or. And so what's cool about this is that we have various different studies that cover over 694 participants, but covering 3 different studies. And what you could do is you could select all of these results and download the clinical manifest data. Just really highlighting the fact that we're working on many, many different studies, and it's not just a single based, it's not annotated on a single study, let's say. So jumping to the data files tab, we have here essentially, again, the framework regarding the data access. So we have a file authorization column where it's a dynamic icon where it shows if you're authorized depending on your credentials. And so as Adam mentioned, we have 2 tiers. Within the portal environment, we have the registered tier and the controlled tier. So the control tier is governed by the dbGaP process, as I was mentioning, which is what we connected in the dashboard. However, for the registered tier, all you really need to have is the registration process and getting into the portal. So if you're in the portal, then you should have access to these data files. And so the only requirement is that if you do want to analyze certain files, let's say, let me just filter here for registered. If you want to analyze these registered tier files in Kvadraka's environment, then you'll need to be connected to Kvadaka again. So if you're not connected, then a model will be prompted for you to do that. And so similarly, you could save a file set, and I'll just show you what the model looks like for Kvadaka. And so you could copy files to again, this is a live view of what I have in my Kvadaka platform externally. And so you could create directly so I'll write webinar. You could write your project name directly here again from the portal, and it'll create that within your Kvadaka environment. And so you could copy all of these files. So again, if I do that here, I should get a prompt, and you could click here the open project in Kvadaka. So you just need to log in. So here we go. And so you'll see that the files will be here, and I'm in the webinar project that I had just created. So this is a really cool feature, really trying to become interoperable with this cloud-based analysis platform. And the Kvadaka platform has a bunch of cool applications. So they have hundreds of heavy-duty computational applications that one can use. And so Matt's going to provide a little bit more information on his part of the presentation. And so the last part here that I want to just very quickly in regards to the portal, we also have column selection tools where essentially you could select which column will appear and will not appear, and you can move them around. And so as you do the export as TSV, it'll export a TSV essentially based on the specific table that you have here, so that you could also do that. Now, going back, I think I'm a little bit over time. I did have a few example queries I want to go over. So maybe we could do a few here. So what I wanted to showcase was the download clinical data for males with abnormal heart morphologies and sleep apnea with DNA samples that have cramped files. I want to showcase, find how many participants there are with Down syndrome and hypothyroidism with files of data type gene expression quantifications. Also wanted to show how you could find how many samples for participants with Down syndrome with available DNA samples, and finally 2 copy files to Chromatica. So we did a few. Maybe we could just do one of them, and we'll just on your own time as well. Or you could do this at the same time as me as well. So we could do the first one here, or maybe the last one actually. So let's just clear all of this here. It's becoming a little noisy, so let's go back and find and analyze file types. So here we have aligned reads generated from peripheral whole blood. So you could go here again in the biospecimen category for specifically whole blood. For participants with celiac disease, and so you could go again in the ontology browser and simply type in celiac disease, and you'll see that there are 37 participants with that. And so again, you'll see 37 participants, 59 biospecimens, and their corresponding data files. And so again, as I just showed, you could select all of these and analyze in Chromatica. You could decide where you want to put it, etc. And so that gives an overview very quickly of what I want to showcase for the portal in terms of what you're able to do currently. And so we also, again, welcome any type of feedback in regards to while using the user Snap platform. You could, again, if I missed anything, if there's anything that was unclear, you could use the Help Center. That'll, again, provide a little bit more onboarding for users. So again, the portal development really depends on what the users want to see. We do a good job in identifying those on our end, but it's always good to get that feedback from users, because there's sometimes things that we could be a little bit blindsided at times.
Thank you, JP. That's absolutely right. Why you should say that, there's only so many use cases and so many scientific questions that we in the design team could think of. We really rely on the users telling us what they need, what type of obstacles they are facing. Now, in that vein, would you please demonstrate the user Snap, how to turn in a ticket from the portal? If you were doing something, you are having trouble, or you see there's a glitch or whatever, something that doesn't make sense to you, how would you let us know? With a screenshot too, which
perfect. I completely forgot to touch on that. Thanks, Joaquin. And so, yeah, I'm not sure if everyone noticed, but there was a feedback button here on the right-hand side, and this is what we're referring to when we talk about user Snap. So essentially, you simply click on that, and you'll notice that your screen becomes a little bit more gray. And so you could, whoops. Oh, I think. Oh, okay, sorry. So I thought that you could select a specific portion of your screen, but essentially it takes a screenshot of your whole screen, and then you write feedback, I love the color of the query builder. So you could write that, or you could write something a little bit more serious where you're seeing an error going on in one of your queries, or anything going on in the portal. It could really be anything. So we're really welcoming feedback, questions, concerns, really anything.
JP, if you touch down the camera icon, does not get you to the screenshot capture.
There you go. Yeah, sorry about that.
So yeah, maybe you want to show us what you mean, or what where are you running into an issue. So now JP is taking a screenshot, and then that gets tagged here to the message that we'll get. And the moment that JP submits this, we get an email. We have a place that like 20 of us are constantly monitoring, where we see not only your message and your email, but you see the screenshot that you took. So the screenshot feature is super helpful.
Yeah, and if you, by providing us your email, we can also connect back with you, around that setting as well. So it's one really very fast way to directly communicate. Just to give an example, I created this query and I didn't get the results I expected. If you just take a screenshot of that, our team can immediately, address it. Or I got this error, and you create a screenshot. You can also just, on the feedback, you can also, don't have to take a screenshot, just to be clear. I expected to see something here and I didn't see it as I expected. So any feedback will come directly. That's one very quick way to do it. Of course, you can also do it through the support email that JP highlighted earlier, but this is a very facile way for us to really understand any issues you face.
Thank you, JP. That was wonderful. Every time you do one of these demos, I learn another trick about the Data Hub. I know that you guys are constantly iterating and adding features. So always great to see you in action here. So we're all right on time. We have next a recorded presentation by one of our super users, Dr. Matt Galbraith, showing how he does an actual experiment and arrives to a discovery related to metabolomic dysregulation in Down syndrome. But I want to make sure that if there are any questions for JP or any comments at this point, that we can address some of those.
And we can come back to the upcoming features afterwards, after Matt's video. Yeah.
Great. I'm monitoring here the chat. So JP, you said you'll do the upcoming features after Matt's recording. Is that right? Okay, great. Okay, I'll keep monitoring here the chat. But yeah, we can look at a Matt's recorded demonstration of how to find a data set, push it to Kavatica, and use a Kavatica application or a piece of code in his case to make a discovery. We don't have the audio, Haley. It's not coming through. I'm going to pause there.
How to find a data set within the Include Data Hub and push that over to the Kavatica platform for analysis. These slides are a full set of slides detailing the steps I'm going to go through here, and the R code I'm going to use are available at GitHub. Feel free to get in touch with me on there. We'll also make these available through the Include Data Hub. We're going to jump right in and go over here to the Include Data Hub. One thing to note is that if you haven't already connected to Kavatica from within the hub, you'll need to do that. It will have a connect button here, and you'll need to log into Kavatica so that the hub can pass data over to the Kavatica system. Within the hub here, we can look up details about each of the studies. For example, the Human Trisomy Project here. You'll enter a landing page that contains some information about each of the studies. For today, we're going to go into the Data Exploration tab here. And more specifically, we're going to jump over to the Data Files tab. And you can see here there's about 11,500 data files here. And we're going to build a query. So, for example, I may be interested in metabolites that are differential in the plasma of individuals with trisomy 21 compared to euploid controls. So how do we do that? How do we identify that data? So first of all, I happen to know that there is a data set, a metabolomics data set within the Human Trisomy Project. So we're going to go over here to these filter tabs, and we're going to choose the study code for HTP right here. We're going to hit apply, and then that places it over, or transfers it over to this study builder. And then we're going to go to the data files and choose a data category here. We're going to choose metabolomics, hit apply. And so we've now filtered down to 418 files, which are from the HTP study that are metabolomics. These are LCMS metabolomics. And so that's it. That's how we drill down to a particular data set. You can save this set of files and give it a useful name. You can also save the filters that you build so that you could perhaps come back later and check if there was an additional metabolomics data added to this. So now we need to select these files. By default, that selects just the items on this page. So make sure you hit select all results, having all of the items selected. And then we will hit analyze in Kavatica. And I've already copied these over to a project, so I'm not going to do that here, but if you needed to, you would then select a project here that's available in Cavatica or create a new project, and then you would hit the copy files button. So now we go over to that project in Cavatica. And if you look, and this is the dashboard or the landing page for the project itself, if you look in the Files tab, we now see that those files are here. There's 418 of them. And so we have successfully transferred files over from the Include Data Hub to the Cavatica platform. They're actually not physically copied, but they are linked in such a way as you can access them. So now what we're going to do is create an interactive analysis. So to do that, we go to this Data Studio tab. And I've already created one running here, but normally you would select Create New Analysis. You would give it a useful name. You can do these in the Jupyter Lab environment. And here we're going to use RStudio. You can change the defaults if need be for more resources, although that will cost you more, and so on and so forth. And then you would hit Start. So I've already done that to save a little bit of time. We have an analysis already running. And this code here is what is also available on GitHub. This is my R script that we're going to run right now. If this is the first time, again, you'll have to install all these packages, but here we're just going to load these packages that we need for this analysis. And I did that to save time. We're going to define some colors here. And then we need to get a list of the files. And so this is where the files live in the project. This is the location of them. And then we're going to restrict that, make sure that we only look at metabolomics files. And so what we have now is a list of 418 file locations. This is one file per individual that had these measurements made. And so what we need to do is concatenate those files. That should take us about 18 seconds if you've already accessed the files previously. And what we're doing here is reading each file in individually and concatenating them together. Great, so that takes about 20 seconds. And what we have now, and we need to build this data in such a way as we can use it for linear regression modeling. That's the test we're going to run here that tests for differential abundance of each of these metabolites between the trisomic samples and the euploid controls. And so we're just going to select the values that we need here, which is all we need is the lab ID, the metabolite that's being measured, and this value here, which is the relative abundance value. And normally we would bring across and join to demographic and clinical data here, such as T21 status. I'm going to cheat a little bit here to save some time. I can decode and add that variable for trisomy 21 status from our sample identifiers here. So we've added that. We now have a variable that says whether they were euploid controls or individuals with trisomy 21. We're going to remove some outliers very quickly. In this case, it doesn't remove too many values. We do a bunch of other checks here to make sure that this data fits the assumptions of the linear regression model. I know that this data is good. And then we're going to nest this data at analyte or the metabolite level. That gives us 174 rows. That's 174 models that we're going to run with this linear regression. And all of the other data is packaged up in this nested data frame here. Very efficient way to carry this out. Okay, so we now have that data packaged up, and we're going to run this linear regression model. And what we use is this map function, which allows us to run that model across individually across the 174 metabolites. Here's the formula for the model. So we're going to take the log2 of the relative abundance value as the outcome variable and the karyotype or trisomy 21 status as the predictor variable. We're going to run that, and then we're going to use this broom tidy function, which extracts the results in a nice format for us. So let's do that. We'll run this. Usually takes about 1 second. Great, that's done. And so what we have now is a set of 174 linear models. You can see them in this fit column here. And then we have the extracted results from each of those models in a small table, again, nested per metabolite. So now we need to expand that back out and extract the results in a nice format that we can use. And this is a very quick demonstration of how to do that. So now what we have is the log2 of the relative abundance in this case, the euploid controls and the trisomic samples with the fold change, and we have a p-value. Because we've carried out 174 different hypotheses, we need to do some multiple testing correction. We're using here the Benjamini-Hochberg or FDR approach. You can see we now have an adjusted p-value here. And then we're going to do a little bit of quick formatting to tidy things up. And so that's our final results that we can now use to examine which metabolites, and you can see these are sorted by p-value, so these are the top most significant metabolites listed here. We can also visualize that in a more summary format using a volcano plot. Zoom so we can see that. So that's just showing us the log2 of the fold change up, things that are up in trisomy 21, things that are down, versus the confidence level or the p-value. We can save these files out and they will become available in that Files tab. We could also make an interactive version of this plot, which allows us to hover over the points and read or identify what the names and the fold changes are of each of those. So we probably want to look at some of the actual data. So we're going to take that data that we built for the regression model so that we're using exactly what the model looked at. We're going to filter to those top 2 metabolites, and we're going to make a plot here. And so you can quite clearly see that the top 2 metabolites by p-value here have, on average, an increase in the plasma of individuals with trisomy 21 versus the euploid controls. So hopefully that gives you a good sense of what one can do by finding data sets in the Include Data Hub, pushing them over to Chavatica, and at least a quick sense of how to do that analysis. I'm happy to answer any questions if people have further questions on that. Thank you for listening.
Thank you, Haley, for sharing Matt's video, and Dr. Galbraith is on the call if there are any questions about this. You know, I want to highlight that we're mindful that Matt is a super user who has an understanding of RStudio, and he was, you know, showing you his pieces of code in RStudio. You don't have to be, you know, if you go to the Chavatica platform, as JP explained earlier, there are a lot of applications already ready for deploy, depending on what you're trying to do. And I don't know for sure, but there may be an application there to look at metabolomics, differential abundance, you know, metabolites by 2 comparison groups. So something that, while I monitor the chat, something I want to also clarify. You saw that when JP was going into Chavatica, he was being asked about a billing group. And then Matt casually commented, you know, you don't want to, that, you know, the more you compute, the more expensive you may get. I want to address this head on. There is no reason anybody on this call should have to pay for any money to do analysis in Chavatica unless you are doing some outrageous amount of computing, because we have a cloud credit program that you can apply for and get credit to compute in Chavatica. I should also point out that moving files to Chavatica doesn't cost a penny, right? So when you do that push to Chavatica and you have the files over there, that doesn't cost any money. It's the computing time that is charged. So I'd like to invite Dr. Huiqing, you are Huiqing Li, a project scientist at NHLBI, who just posted his information on the Cloud Credits Pilot Program. But maybe, Huiqing, you can take the opportunity to explain to our users how to get these credits.
Sure, thanks, Joaquin. So the Include project offers, you know, cloud credit for data analysis on Chavatica. So we have an Include Cloud Credit Pilot Program. I just posted in the chat box. So we want to use this opportunity to provide cloud credit to you know, users who will analyze Include data, or who could provide tools to help analyze the data and share with the community to help analyze the data. And if you can see more information here in the link. So we have 2 phases. For phase 1, we offer $1,000 cloud credit, and we only have a few questions asked. Just request that from me. Currently, it has my name here, but in the future, we will have a Include product email listed on the website. And on the second phase, after you finish your initial 1,000, you could request for additional cloud credit, which is up to 20,000. You know, and there are a few questions we will ask you to address, but those are, you know, like administrative questions in general. And the turnaround time is about 4 to 6 weeks after you submit your questions and submit your mini proposals to us. And the Cavatica, the 7 risk team will set up a bidding group for you and offer you 1,000 for the phase 1. And both the DPC and the 7 risk team will help you to guide you how to use the cloud credit. This is one opportunity. The other opportunity is, if you need additional support, the Include product has a RO3 for a small research grant on data analysis. Of course, it also covers data sharing because we really want to encourage the community to share the data. And another part for this FOA is to encourage data management and harmonization. So overall, the Include project has, there are other funding opportunities. If you are not aware, I post the link here for your reference. If you have any cloud credit pilot program related questions, feel free to reach out to me. I will post my email address here for your reference. Thank you, Joaquin.
Thank you, Huchin. That's great. And I know firsthand it's very painless to request the credit. It's not a cumbersome process. So, and for those of you who are at your institutions don't have a cloud computing environment, this is a big saver, a big money saver and time saver. You don't have to have your own cloud instance, your own super server. Now, I should also like to demystify that a lot of the analytical exercises don't require a huge amount of, cloud computing. We'll be talking about pennies of the dollar, to do a lot of things. It does get intensive, when you're doing a lot of RNA-seq or genome analysis or some of the big data types. But the exercise, for example, that Matt demonstrated with metabolites, where it was only 174 metabolites on a couple hundred samples, that's not going to consume a lot of computing power. So I want to make sure that you go into asking that $1,000 credit, with confidence that they go a long way. $1,000 goes a long way. And if you get really heavy in your computation, you can then scale up to 20,000. Great. So that concludes this piece. We're going to go to JP. Please do enter your questions in the chat. I'm monitoring. JP, very excited. I'm very excited about what you're about to show, which will be very helpful for people like me who don't know how to handle RStudio, the important analytics. Go for it.
Thank you. And very cool to see the whole life cycle of taking registered tier data all the way to Cavatica and doing that analysis. So very exciting stuff. So we wanted to give everyone a little bit of a taste of what's up and coming in terms of features for the portal. And so, as I mentioned, phase 1 was really in regards to finding, accessing data, making that, having that interoperability with the Cavatica and analytical framework. And so in terms of features for phase 2, we really, as I mentioned, want to enhance the phase 1 product. So the first piece that we want to improve is the new, we want to create a new summary view. Currently, as you all saw, the summary view is limited to a representation of 7 facets, which includes the 2 different sunbursts that we have here. And so you'll see in the screenshot, this provides a little bit more of an interactive view and an overall view, a complete experience to see, because we're going to try to incorporate, if not all, but almost all the facets that we have in the portal. So for those that are a little bit more visual, then this is going to be a great option for you all. Of course, we're going to be, this is going to be a customizable layout where you're going to have a list of charts, and you're going to be able to convert your charts into tabular format, where you're going to be able to export that data and save the chart images in PNG as well. We also want to incorporate a type of comprehensive cohort report in PDF format, which will essentially capture the metadata across the 3 different entities that I've been discussing. So the participants, biospecimen, and data files. So that's another feature that we'd like to improve on. And so the other portion that we want to improve as part of phase one, in addition to phase one, sorry, is incorporate entity pages. So what are entity pages? Very simply, well, it is very simple. It's just a detailed information page on a specific entity. So again, the entities that we have currently in the portal is the study, participant, and files. The biospecimens are possibly going to go into the participants. So we're going to concentrate and prioritize these new pages to provide more details on a specific entity. And as I was mentioning, while we're going to be developing the variant exploration tool, we're also going to be incorporating new entity pages for the variants and genes. We've also been exploring the idea of having an entity page for co-occurring conditions in the context of Down syndrome. So let's say we could select the top 30 or 40 co-occurring conditions. What this entity page would have, it would be essentially a definition of the condition, the impact, associated literature, and its prevalence in the context of Down syndrome. And within this page, we're also going to see the relevant Mondo and HPO terms associated to, we're going to see the number of participants with those specific Mondo and HPO terms, as we've been saying. And we're also exploring the idea of having a crowdsourced a collaboration with community users. But again, this is just an idea. The real exciting piece is going to be the integration of the germline variant exploration tool. So what this tool will be doing is really going to enable users to search across millions of annotated germline variants from INCLUDE's participants with known co-occurring conditions. So what we're going to do is we're going to start with the studies that have that share programs between Kids First and INCLUDE. So we're going to start with that, and later on, as we progress, we're going to be incorporating the variant data for the other studies. And so you'll notice here that we have germline variant data. It'll be in our plans to incorporate somatic mutations and copy number variations as well down the line. So if we look at the mock-up here, you're going to notice that the interface itself is very, very similar to the data exploration page. And we do that on purpose so that it's a lot more intuitive going from one page to the other. So you'll see here that we have the query builder, we have the table of results essentially detailing the variants at a row level, the type of variant it is, so it could be a deletion, insertion, etc. We have a few external databases that are connected to the variants. So we have DBSNP and ClinVar within NIH, and we have the consequences of the specific variant. So it could cause a frame shift, for example, and different frequencies. On the left-hand side, similar again, we have faceted search criteria where you're going to be able to search, for example, by genomic location of a variant based on the HGBS nomenclature. You'll be able to look through affected genes based on the variants, the pathogenicity, so clinical and functional aspects of the impact of a pathogenicity of a variant. And we're also going to have the frequencies associated to the variant. So this will be the populational frequencies within the INCLUDE Data Hub, but we also have a connection with external databases that are very well known, like NOMAD, TopMed, or the 1000 Genome Project. And lastly here, another very important add-on that we're going to be doing is users are going to be able to filter by affected participants' phenotypes and diagnoses. So what this means is that we're going to be able to find variants based on a user's phenotype and diagnosis. So let's say you have a question of, I want to find all pathogenic rare variants for celiac disease and Alzheimer's disease. Well, you're going to be able to filter that, and it's going to provide all the corresponding variants for that search. So this is very exciting stuff. We're going to be working hard on implementing this in the next year. And so, as I was mentioning, we're also going to have a variant entity page, which essentially is just going to provide more detailed information on a specific variant. So here you'll see that we have a summary section where it's a little bit more the chromosome, the genome build, et cetera, and again, various external databases. We'll also have sections for the consequences. So the impact of a mutation on a gene. And this is going to be at various different ensemble transcripts. So you'll see different predictions here with SIFT and polyphen2, HVAR, et cetera. So you'll see the impact there. We'll also have the frequencies, as I was just mentioning, shown here within a specific section. So you'll see the frequency that's happening, that this variant is occurring across the INCLUDE cohorts, the NOMAD databases. So they have a very rich database of variants and top med and frequencies and whatnot. Another section that we're going to have, well, the next two sections are really the pathogenicity, as I was mentioning. So you're going to be able to see and correlate the clinical associations between a variant or a gene on a specific condition. And so we follow and utilize the definitions of ontologies again here. So using OMIM, ORPHANET, HPO, et cetera, to define those clinical associations. So this is the plan for the entity page of the variant. Another very important, the second part of the phase 2 will be concentrated on the online analytics and visualization tools. So the reason why we want to do this is a little bit more on the INCLUDE Data Hub side, so on the web-based side of things. It's more so to enable non-bioinformaticians to run advanced analyses on participants' data directly from the portal. So you'll be using data from the INCLUDE Data Hub, and of course, you'll be doing that directly for ease of use and ease of access within the hub. And so the first tool that we want to prioritize is the cohort comparison, where you're going to essentially build and compare customized cohorts by participant, gene, and variant sets, comparing clinical characteristics and whatnot. So as I was mentioning earlier in the presentation, in the dashboard, we have that save set widget. And so with those saved participants or genes or variants, et cetera, you're going to be able to launch this cohort comparison tool. The second tool that we want to build is the enrichment analysis tool. So essentially, you're going to be able to launch an enrichment analysis to obtain a list of enriched annotations using a set of genes saved from the variant explorer. So the enrichment analysis could cover ontologies like the geoterms in regards to the molecular level, the biological level, so we get those functions there based on genes.
So JP, I have a question about enrichment analysis. So you mentioned Go terms, but do you think other things can be accommodated as well, like gene set enrichment analysis or Metascape? What is possible here?
That's a very good question. We haven't explored, perhaps we're going to start with the more simple Go terms to start. So the biological and molecular portion of the Go terms. I see that Vincent, yeah, go ahead, Vincent.
Yeah, so I can answer that question. So there's no limitation actually about the gene set that we can implement, integrate in that tool. So we wanted to start with the 3 Go ontologies, and then maybe some reactome, and then we can add any other database of gene sets, basically. Great. This is formally how they are treated in that tool.
So the user will be able to choose perhaps which.
Yes. When they will launch an analysis,
yeah,
they will select what we call the universe. So the set he wants to analyze with this tool.
Great, thank you, Vincent. Thank you, JP. Back to you.
And so the last part of the analytical tools that we want to implement is a gene expression tool, where essentially you're going to be able to visualize and interpret RNA-seq and microarray gene regulation using a heat map. So really looking at the upregulation, downregulation of those genes. And all of these tools, as I was mentioning earlier, again, it's going to be within that dashboard, your personalizable space. And we're going to have an analytics section where you can, again, you see these 3 tools. And so this is really meant to have an ease of access and to make quick launches of these analytical tools. You'll also notice that we have a recent analysis window here, essentially providing a type of history of the analysis that you've done in the past. And so the reason we have this is mostly because you'll be able to save the parameters that you used for the first analysis. Let's say you did the cohort comparison or enrichment analysis and you had X, Y, and Z parameters. This is going to be saved so you don't have to repeat that process. And so we're concentrating here on these 3 tools, but in the future, if there are more common bioinformatic tools that supported by the community, then we could definitely change these, and we'll be continuously adding some as we go along. So I believe that that's it for the portal piece. So hopefully everyone got some new information. And if there is still, again, any questions in regards to anything, the Help Center is there, UserSnap is there, you have our email. So definitely don't hesitate to reach out. And I guess this is going to be the discussion piece. So thank you, everyone.
Thank you, JP. Great job. I'm salivating about all those cool tools that you show that will be coming here within the next 12 months or so. And again, we want to follow the guidance from the users. You know, if there are some preferred type of exercises or applications that would be very popular, we want to hear about that. And we'll make sure to keep a strong outreach campaign. We're going to have these webinars twice a year. We have our office hours where you can come with your questions or ideas, and then we'll have a strong presence at a number of conferences as well to learn from our user base. So I'm monitoring here the chat. It's been quiet for a while. Yeah, we wanted to make sure that there's plenty of time to address any questions or concerns that haven't been addressed yet.
Yeah, Joaquin, I want to mention that, we really want to welcome feedback, like you said. If you have, as a user, if you have any questions, concerns, feel free to reach out to the DCC or to me directly. We will be very happy to hear your thoughts to improve the portal and the platform. And I also want to share that Joaquin mentioned that for users who don't have high performance computer system, it will be great to use the cloud. However, I would add that even for users who have high performance computer system, they would benefit a lot. And because you can see how convenient and and how convenient the cloud computing is, and very time costly and cost effective. Yeah, time efficient and cost efficient. Okay, there's one question from Adam.
Yeah, Adam Smith. What happens to the large intermediate files that are generated while using Cavatica? For example, while analyzing whole genome sequencing, how straightforward it is to download these results locally. So this, I don't know if Matt is on the call, but also we have Michele. Michele, maybe are you comfortable taking this one? It seems, or Surya. It seems like a Cavatica question.
Yeah, I can take the question. Thank you very much. Hi, this is Michele from Seven Bridges. So basically what happens in Cavatica, we have a feature that's called memoization, where basically you have the ability to create the intermediate files are retained for a certain amount of period and then automatically get deleted after. This app helps you in case your task stops midway, and so you can restart from half the task instead to rerun it from the beginning. To go back to to hit your question directly, if you want to preserve the intermediate files they generated during the WGS, for example, you want to keep the BAM, you can simply create an output on the WGS workflows, and basically the BAM becomes one of your output data, and then that file will be retained. It will not be treated anymore as intermediary, but simply will be stored, and it will be one of the results of the WGS. Once that is done, you can always download the file locally if you so wish. There is a button that says download, or there are like other 2 or 3 ways to download it by API and command line. They are basically available on the docs. At the same time, you can also investigate the BAM locally via the genome browser that is embedded on Cavatica, or you can, if you want, bring up an IGV instance inside the data studio, like Matt was saying, to basically, or any other type of viewer that you might want to use directly on the Cavatica. That will avoid downloading lots of files on your computer, and also you will basically save bandwidth and time. So I hope that helps.
Thanks a lot. Yeah, very helpful.
Super.
Thank you, Adam, and thank you, Mikhail.
Yeah, I want to add, I want to tell Adam, so yeah, you can download, you are allowed to download the data. However, NIH is highly recommending investigators to do cloud computing, to use the cloud. And another thing I want to add for cloud computing is we have different platforms at NIH now. The so-called NCPI, NIH cloud-based interoperability effort, platform effort. So for example, for Down syndrome, there are so many co-occurring conditions, and you may want to co-analyze data using data from different repositories, NIH repositories, and NCPI would facilitate that, and you will be amazed at how well it is, how much you can do in the cloud. So if you're interested, let me know. Thanks.
Yeah, and that, Hu-Ching, we didn't elaborate on it today, but a ton of the work by the DCC team is making sure that the way we run our business here is compatible with the other large resources like the NCPI, so that tomorrow when we become part of the NCPI or whatever umbrella program, the data that's being collected in INCLUDE can seamlessly be integrated with the other large data resources out there. That doesn't happen overnight. It's a lot of work to make sure that we are following the standards or the dictionaries or what have you that are necessary to enable that interoperability. And I see that Michele has a comment or a question.
Yeah, I have just a quick comment on building on what Eugene was saying. When you go on, for example, on the Cavatica platform, one aspect that maybe it's a little bit underlooked, but I think it's extremely important, is the collaboration, where you have basically projects where you might have somebody that is more bioinformatic advanced, or they have like they are like more dry, they have more dry, wet instead of wet lab skills. They can run the tools and they can run the workflows. They can create like notebook and basically have the analysis there, and other people in the group can simply join on the project, and then they can actually see the results over there and then expect like the output over there. So it's more like there is like that type of collaboration that is available, and this basically also happens in a kind of like a private project, so it's only visible to the people that are member of that project, so there is no problem about somebody else seeing that data or anything like that. So everything is extremely well purposed for this type of a collaboration. And one last bit that I want to stress also is like that if you are in a situation where somebody in the lab say, hey, can you run that task for me? Can you run that task for me? It's you can have, if you use something like Cavatica, somebody can create the workflows for you, like a bioinformatics person in the lab can create like a workflow. This is like our workflow that we want to use in the lab, and you can simply then copy, you pass the sample there, and then you click run, and then basically will do all the hard work for you and result in the results. And with that, you get also like a provenance and reproducibility, because the workflows are based on standards. So there's a lot of nice and cool, interesting things just under the bonnet. So totally, totally suggest to try to give it a go. Thanks, Joaquin.
Thank you, Michele. All good points. Very good. And Surya has put some documentation here as well. It's all online, but good to have the shortcuts here in the chat for you to save in your bookmarks. So that concludes, our agenda for today. Heading into the holiday season, good wishes to everyone, whatever type of holidays you celebrate. And you'll be hearing back from us with more outreach events at the start of 2023. If there are no more questions, I'm happy to wrap it up here. I want to thank again Adam, JP, Matthew, Hu-Ching for the presentations, and we'll be in touch. Thank you, everyone. Have a good day.
Thanks, everyone.